Hi, hello everyone, and welcome back to my YouTube channel Spotify Learn. Today I'm here with another video that is about the fourth module in DSA. Let's start without further wasting time. If you have not watched the module 3 up to module 3, you can watch those 3 modules and come here. I'll explain all the concepts clearly. I hope you will get it. Okay, let's start without further wasting time. See, they have given define an algorithm to traverse, that is depth first search, that is and apply for this. Okay, what is the algorithm here? You can consider G and V, and you have input G and V, that is vertex V, and the output will be edge. E is nothing but the edges, and what is this visited in DFS order you have to write. What steps means, first you will be having mark all the visited as, like, what are all the vertices that is present. You will mark it as not visited because nothing is visited at starting. Okay, you will have vertex V and you will mark V as, and you will print it. And for each adjacency, that is adjacent unvisited, you will have the vertex of V. Next you will call it recursively, that is you will be continuing the same algorithm and you will repeat it until you have all the visited nodes until once. Okay, now let's see what is the algorithm. Visited of V is equal to true, you will print. For each you will have, if it is false, you will print as DFS of G comma U. Okay, next is what is the order of this. See, first, what you can start from anywhere. Okay, and you have to go depth into it. You can see here what they have given. F B, okay, B to C, A to D, B to D, this to this, and here it is E, right? Here it is E, and here it is C again, and here it is G, and this is connected. I hope you got this. Okay, see, what is anything you can start here. Okay, you can start anywhere. Okay, A, if you start, the deeper you can go into B. B again, like anywhere you can start means you can start at any of the point. You can start either at F, either at D, either at B, anywhere. And next you have to visit all the nodes at least once. Okay, that is what we have here. For that, what you have to do is, see, first you consider what are all the nodes that is present. Okay, what are all the nodes that is present? A, B, C, D, E, F, and last is at G. Okay, what is at last? A to G. Okay, that right. Okay, now if you start, what are the having vertices? You can start at F, right? As I said, now if you start at F, you can either visit to B. See, F is connected to B or D. Okay, either you can visit it. B if you go D or F, A, B, F. A if you go C, D, E. C if you go A, G. G if you go, because A is already visited here. G. G if you go C and E. E if you go A and G. That is the traversal steps you have to go. Okay, now what you happen, I'll copy this. See here, if you take this F, okay, F deeper you will go B. B deeper you will go what? D. Okay, D deeper you will go A. A deeper you will go C. C deeper you will go G. Okay, C deeper and E again. A is already visited. Again, if you go deeper also. That is how it works here. I hope you understood this. Next is, what are the Okay, now what is for the given binary tree? You have to write the post order and in order sequence. Okay, they have given the sequence and you have to write the binary tree. Okay, how to write that? How can I say that? Okay, see, let's understand what is step by step. Okay, they have asked in order, they have given us what? G, D, H, B, A, E, I, C, F. Okay, you divide it. This can be in order, right? So this can be left. This is root obviously, and this is what? Right. Okay, you divide it. Root what? A you write on first. Okay, now A's left is what? A's left is what? B. Okay, and next what you need to do again, you have to construct the in order, right? For that, what you have to do, the step is, see, now you constructed that left. Okay, now you will take this 3 as a group. Okay, here what is root? D. D you will be taking as root, and this is left, it will go to left, and this is right, you will be taking here. Next, EIC. Okay, for EIC, what is happening here? EU, it is what? You leave it. Okay, let's see what is it. Okay, now you take ICF. Okay, ICF, if you take, what you can do is, see, root is what? C. Okay, that will go to C. Left is E. Okay, next F is right. Okay, next is I. I is remaining, you will put it to right. That is because E is the root. Okay, E is the root. Okay, next if you see the post order also, G, H, D, B, I, E, F, C, A also. If you take the same binary tree should be constructed. Okay, I hope you're understanding. Okay, first what you need to understand is, you need to understand that what they have given. First you need to understand what has been given. Okay, now in order to do that, see, this is the post order sequence, this is the pre or in order sequence. This also you divide it. Okay, post order means this is what root, this is what right, this is what left. Okay, now what is the last post order element? You have to find out the root. You got it in both the elements as A. Here also you got, here also you got, you wrote it as it is. Now by doing this, you split it, GHDB, right? GHDB as left and EICF is a IECF is a right. Okay, now if you divide that, IECF, that is right. Okay, now when you have to do the left, left means what? This is left. Okay, you will take it to left, and the right is what at last? Here it is C, and next it is D left, and that corresponding, that will be, see, when you have to move to right, here it is F, and the corresponding is H is what? If you take this three, it is right. Next root node is what? E, and it is left, it is right. Okay, E and I. Next you will take the same and you will construct the final order, that is A, B, C, D, H, D, and E, F, and I. Okay, that is how you construct the binary tree. Next is they have given define selection tree. It is a complete binary tree that when its leaf nodes will be there. Now that will represent a set of elements for each node, internal node. Store the result of comparison between two children, and it will contain selected element, either minimum or maximum. When you have this, they have given, you have to construct, see, when you have to construct a tree. Okay, like a box, you remember. Okay, and next is you have to take the minimum value and you have to be constructing, that is, and when you get the final answer, you have to take the minimum of the particular 10 10 10 20 20 20 and all. And next is what is the having that, what is the winner list can be there means 6, 8, 9, 9, and 10. 6, 8, 9, 9, and 10. When you have to construct this, you can do as the easiest method of all, shall I say. When you have the easiest method, you can do it easily. Okay, when you want that, see, you can see here, first you write the root. Okay, 10 and 10. Here also they have given 11, and here also they have given 10. The same way you write it for all. When you write it, you will get it as better understanding. See here, what I'll say is, you forget all this. Okay, let me erase this. Sorry. Okay. Now you write down what they have given, guys. What they have given. First G, D, H, D. As I said, A you consider here, and here write it EICF. Okay, EICF. Now again, what you will do? GHDB you have to consider, right? So what you will do, B you will take it as what? Root node. Okay, root. This is post order I am doing. Okay, post order, this I am doing. you will take this as root. Okay, now you remember this will be coming here. So what you will do, a will be as it is, b will be there, and next what you will be having, g, d and h. Here what you will do, this is what, that is last one, this you will be having EICF, right? That is, you will be having the root as what, C. C you will be having, GDH is present and EIF is present. So what you will do in GDH, D will be what, root node. This you will move here and this you will move here. And here also the same way. This will be what, here it will be moved EF and I will be moved here to right. The same way you will do for in order also. I hope you understood this question. Next, if you want the same method to do, next when you have the have given such as 10, 9, 20, 6, 8, 9, 90 and all, when you want that you have to construct 16, 15, like you construct this 16, 10, 15, 16, 9, 20, 38, this full, and you construct till what they have given. Okay, when you want to do that, first you take the element as minimum element. Okay, when you want to take the minimum element, regardless of what the winner or loser, you have to just find out the part that is minimum or maximum. Okay, so consider means what you have to consider elements. Among these elements, I will tell you what the step you have to follow. Okay, first you take the this, okay, this first element, and what it is, minimum 10. Okay, write on all here. Okay, when you take here it is 10. Next, what you got here, it is 9. You know what you will do, something. All you have to do is, here you got 20, here you got 6, and here it is 8, 9, and here it is 90, and here it is 17. Okay, the same way you'll be having for everything, the minimum. Again, the same way you will be constructing the root nodes for it. This will be what, down element, that is minimum. Again, next you will be considering what is the next that is having the right, it is 9. And again you will be having next, this is right, and this will be having 6, and this will be having 9, and this and next is you will be having here you will be having as the same way you'll be constructing the minimum. And what you'll be doing here, it is 6, and here it will be what is the minimum, that will be having 8. Okay, 8 is minimum. Here it is minimum what, the same way you'll be having minimum as what, in 90 and 17 it is 17. The same way you'll be having in 6 and 9 what it will be minimum, that is 6. Okay, and the 8 and 17 you will be having minimum as 8. The same way 6 and 8, 6 will be minimum. The same way you will construct like a tree. Okay, you will get a tree. Now what you have to do is you have to construct a winner list. Okay, see what is the winner list. First you got this is 6 root. Okay, next you'll be considering 8, and next you'll be having again another 8, 9. Okay, next you'll be getting 9 here, so you change it to 9. Next again you will be adding 1. Next you'll be taking the next element. The same way you're doing for every element, and you'll follow the same step. I hope you understood these steps. Okay, next is binary search tree, is also same type, that is having in order, that is left, root and right, root, left and right, left, right and root. The same way you can do in the recursive function is also the same. You can see these programs. Okay, now when you have a forest, what is a forest? It is a collection of disjoint trees. Each tree is a forest, many have one or more children. That is, but no single root for the entire structure. They have given a pre and post and in order. See, in this, what you have to do is pre-order. Pre-order means what? First, what you will get, root B, and that left is what, D, that right is what, E. Next again that is root, I is left to that, J is right to that, again F is over, left, right and root. Next you have to see here, C is the root, G is the left for it, and K is the element with corresponding, there is no left and right, so there is middle, that is next is H will be corresponding next to it. Next, you can see the same way post and in order you can do. What is disjoint set is? It is a data structure that maintains a collection of mutually exclusive, not overlapping sets. Okay, it is having either find of x or union of x y. Next is what is having graph. Okay, and you have to show that it is a representation of graph. See, what is a graph is non-linear structure, data structure. It is a type of data structure that consists of a set of nodes or vertices, edges that connect between them. When you have certain elements between them, you connect between them. That is called as nodes. You write the adjacency matrix. That means 0 and 1 is connected. You will write as 1. And 0 is 2 is connected. 0 and 3 is also connected. And 0 to 0 is not connected. The same way the diagonal will be 0. Rest all elements will be 1. And the adjacency list, if you want, see 0, 1, 2, 3 are elements you will correspond. See, 0 is connected to what? 1, 2 and 3. 1, 2 and 3. 1 is connected to what? 2 and 3. 1 is connected to, okay, 1 is connected to 0 to 0, 2 and 3. Okay, 0, here it should be 1. Okay, next is you can see here 0, 2 and 3. What are the elements that you have? And next, this is for the next, this is nothing as 1. Here it is slash. Okay, next you can see here 1, 1 and here 1, 1, 1, 1. Here it is 0, 1, 2, 0, 1, 3. Okay, the same way you can see here. The same way you can see this module chapter. If you want the same PDF, you can DM me on Instagram. My Instagram account is Spotify_learn. We will be sharing immediately the PDF. And thank you for watching the video. Make sure to like, share, comment, and subscribe to my YouTube channel. Until then, meet you on the next video. Until then, bye bye.